fusion power, and how to make compact, tileable reactor designs. So before we dive into the reactors themselves, we need to go over some numbers. Here is a table of number of cores versus number of turbines, and if you look at it closely, you'll notice that they pretty much all end in 8. And if you try to fit an equation to these numbers, you'll realize that the number of turbines is equal to 10 times the number of reactors minus 12. So 4 becomes 40, minus 12, 28. 10 becomes 100, minus 12, 88. This is very useful for quickly calculating how many turbines you need for much larger reactor designs. Your power will go up by 1 gigawatt for every 2 cores that you add. So every 4 cores adds 2 gigawatts, etc. Second set of numbers you need to know. A cryogenic plant processing fluoroketone handles 4 per second by default, and the fusion reactor outputs 4 a second by default. So these are 1-to-1 by default with no modules in the cryogenic plant. If you have full speed modules in your cryogenic plant, it goes to 5-to-1, meaning a single cryogenic plant can handle 5 reactors, and you can tailor the number of speed and efficiency modules in your cryogenic plants so that you save a little power on your cryogenic plants without having more processing than you actually need. The entire system is obviously a closed loop. So on to the reactors themselves. Here we have some basic reactors. These are going to be some of the more common ones you're going to use on a platform, for example. We have our 1-core reactor, pretty basic here. Shouldn't be hard to figure out. And here we've got a couple examples of 2-core reactors. This one may look nice, but I'm not a big fan of it because undergrounds don't reach all the way across, so inputting the fuel is kind of shitty. Having both reactors on the same side and exposed is much better, so these are the 2 designs that you'll find in my blueprint book, which will be in the description. Of these 2 designs, this one may look a bit nicer, but I have found this one is more useful on platforms because it has a slight indentation here. Like, these reactors are not flush against the edge, they're slightly inset, which gives room for inserters when putting it right next to a hub. And this one frequently winds up taking up less space than this one. Over here, we've got some 3-core reactor designs. This one here is just as a demonstration to show that if you put them in a row, you get 200 megawatts here with only 100 neighbor bonus, 300, and then 200. But if you put them staggered like this, you will get a full 900 megawatts of power. So this one is only putting out 700, and this one is putting out the full 900. With larger reactor designs, you will find that this pattern extended is obviously going to be the way to go. I would also highly recommend, when designing your reactors, making sure that your plasma is all connected together so it can flow freely between all the reactors, so you only have to worry about hooking up one output, and handle the fluoroketone input from the side, or potentially, going around from both sides. So if you're looking at these a bit, you might notice a little bit of a pattern. And that pattern is going to be that when we have 2 turbines coming in, with, say, the fuel coming in from the bottom, if we attach like that, and like that, and like that, so it's just 2 to 2 to 2, it creates a very nice tileable pattern that can be extended essentially infinitely. This is the core of my fusion reactor designs, especially the larger ones. This helps keeps things very compact and organized and wastes very little space while simultaneously giving plenty of room for piping. I do not recommend attaching end-to-end like this unless you were doing it with a very specific purpose. There's only one reactor that I've used that in right now, and you'll see that in a bit. Because if you attach them end-to-end, what happens is you wind up with stuff like this, where you eventually can't really effectively extend it much more. Like right here on these sides, I can't attach that to there. So you'll get like some, okay design, but it doesn't tile as nicely, and I recommend never using the front output for the plasma unless, as I said, you have a very specific reason to it. Have it come in the back and out the sides, and keep repeating that pattern. So, onto a couple of tileable designs that I've made, and again, these will all be in the blueprint book. We have an 8 tileable design here, which can be extended quite nicely. This is essentially the same thing as this, and you can just keep extending it The pipes connect to both sides quite nicely. Run the power poles down the sides, or you can put it on a platform. Works great. Same thing here. We have a 12 tile design. This one, if put on a planet, needs to have its substations on the side. But again, you just can keep extending it infinitely over and over. So this is 12 turbines per each tile. This is a variation on the 12 where I moved the inputs to the side. This is beneficial when designing some reactors. Again, we'll cover that in a moment. And once again, you can tile this infinitely, straight up and down, no problem. It's worth noting that stuff where it says end pipe connect in my blueprints means that once you're finished extending it as much as you want to, you need to connect the pipes at the end, well, more like that, so that the left and the right connect properly. If you don't do that, then by default the pipes will be separate and you will have fluid issues flowing to your fluoroketone plant. A note on width. So about 12 turbines is the widest you can essentially really make this in terms of planetary reactors, because if you get any wider, you can see that up here with a 16 tile block, the subs no longer reach the turbines in the middle. At least normal ones don't. You can get quality substations to increase the range, but I haven't really been designing around those. So yeah, to me, this right here, these two are the go-to tiling blocks as far as planetary reactors are concerned. But just for an example, we've got a 16 tile over here with rare subs, a single rare substation in the middle. We'll reach everything, and now once again, you can keep extending that over and over. This outputs on both sides, and you have to make sure when putting the fusion in, it's coming in again on both sides. So, onto some reactors designed with those tiling blocks in mind. Oh, and I almost forgot to mention, reactor core tiling itself. So when it comes to tiling reactor cores, this is the block that I came up with. I highly recommend this because it tiles perfectly, and it uses the right here. It actually just barely uses the maximum length for both the pipes and the undergrounds. And you know, you notice that when you're designing something, if something tends to line up this perfectly, it's like, ah, yes, this is kind of what the developers intended, kind of thing. But you can just keep extending this over and over and run your fusion cells down the belts and your fluoroketone on the sides. You will need an end connect for the fluoroketone. But this extended over and over, again, is essentially the reactor version of my turbine tiles. There's only one blueprint for this because there's only one you really need, and it's kind of hard to improve on this. And yeah, there you go. That's how you tile your reactors. So here we have a 4-core reactor, 1.4 gigawatts, using the 12-tile blueprint, which outputs in the middle. This is this tile, this one over here. If we copy-paste this, you can see. And, well, it's backward. I have to flip it, but there you go. And this being a 4-core is 28 turbines. So we have to cut off a little at the end and connect it otherwise. But, yeah, that's essentially how you build your reactors. You take your Tilable cores, extend however many you want, and then you keep slapping down these 12 turbine blocks over and over until you have the appropriate number of turbines. You know, it's multiples of 12, so you'll have to shave a few turbines if you don't want to over ratio once you're on the very final block, unless it happens to line up perfectly. And there you go. Nice, dense, compact reactor with a relatively little wasted space. Over here, we have a 6-core reactor using the side input 12-tile block because it fits slightly better with this, needing more than one fluoroketone plant, because remember, with maximum speed modules, it's to 5. So this has half speeds, half efficiencies, and that keeps it going smoothly. Since this is a 60 turbine reactor and 48 turbine reactor, and 12 multiplies into that nicely, then we don't have to trim any turbines on this reactor. It gives you a nice, comfortable 2.4 gigawatts, looks amazing, and this is going to be one of my mainstay reactors regarding planetary reactors. I'm a particular fan of this design right here. It's worth noting that all my designs are designed either around platforms or planetary, and I am not putting bots in on my blueprints by default, because if you're going to bot feed your reactors, then belting and all that becomes absolutely trivial. You don't need me to tell you how to do that. So all my designs are essentially going to have belts in them by default, assuming that you will be belting things in. This gives you better flexibility, especially in regard to platforms where you can't have bots to begin with. So obviously we can take these to more logical extremes, and that's what's going on down here. These are just proofs of concept. I didn't hook up the fluorocatone plants to this, but as you can see, this is using the 16 tile block for a 22 core reactor. You can just keep extending it over and over and over. And same thing here, we have a 24 core reactor, which is 19 12 tiles. I picked the number of cores based on how many intact blocks it lined up with nicely, but there you go. Pretty easy to figure out how the rest would go. You can easily scale these up or down depending on how big your base is and how much your power you're using. And that's essentially how you design infinite planetary reactors and tileable ones. And there is essentially no limit to how long you can scale this. Well, there's kind of a limit. It's going to be your pipeline extent. At some point, you're going to need to work in pumps. So this one's at 229 right now. But yeah, at some point, the pipelines pumps will start messing with that. But I have not designed any reactors that get large enough that that becomes an issue yet. So you may be thinking, okay, all of these are essentially designed around power poles so far, at least the ones I've covered so far. And if we're on a platform where you're going to be using a lot of fusion power, because fusion is obviously excellent for platforms because it's so compact and doesn't have any waste and also doesn't require water like nuclear, things change because you no longer need the power poles because the platform itself powers everything. And that brings us to some slightly larger designs. So we have our 28 tile block here. This is essentially just a larger version of the other ones. Again, now that we don't need to worry about power poles, this can just tile over and over like that. Again, we have end pipe connect written here, which means if you mouse over each pipe and look carefully, you'll realize they don't connect, which means once you're finished extending it as far as you want, you just need to give it a little end pipe connect so that both sides actually connect, unless you're doing something weird with the fluorocatone. But in all my designs, all the fluorocatone is on one side and the reactors are on the other. We have the same thing here with a 48 tile block. This is 48 turbines now in a single block. Again, needs an end pipe connect, but the principle is there. I'm sure you understand it by now. So from there, let's take a look at some platform reactors. And right up here, we have got something went wrong there. We're not even going to look at that. I need to refresh that test. But over here, you can see a 4-core reactor over here with a 28 tile platform right here. And you can keep extending your reactors up, and you can keep extending your turbine blocks down. Now, one thing you may be noticing is that if you're going to keep extending these down and you're going to keep extending these up, you're going to wind up with some really long reactors like this. Now, on a planet, that's not such a big deal because on planets, space is generally not an issue. Aquilo and Fulgora notwithstanding, but on planets, having a very long reactor is not as big of a deal. On a platform, it is a significantly bigger deal. And if you keep extending it, you're going to wind up with this long column and then these really wide blocks, and that all is really awkward. So that brings us to the next logical step, which would be to take the reactors and turn them on their side. And that brings us to this giant proof of concept I've got down here. So here we've got 100 cores and 988 turbines all running. And it's just a quick proof of concept to show that these tileable designs do work pretty well. This pipeline extent is just barely shy of that 320 maximum, but it shows you can get, at least on a platform, a very, very, very large reactor with within one pipeline extent. Obviously, on a planet, things might get a little bit trickier. So this produces something like 45 gigawatts, something like that. I don't remember the exact number. I can't exactly check the platform power right now because there's a bunch of reactors on here and they're all adding up. But you get the idea. This was just a proof of concept to show that essentially, you know, that the tiling idea that I had actually worked. If I can find a spot where they line up better. It'd be easier if I copy pasted it in the right spot. There you go. As you can see, it's just the same block repeated over and over and over. There are essentially two types of blocks here. One where it's going straight down. As you can see, we have one little turbine at the over here that turns the plasma, and then we have all of these right here. This one column over here brings it down, and then they will go to the right. So obviously the next step here is to move on to what would be an infinite tileable platform reactor. And that's what we've got going down here. So we have right here our infinite reactor. This is our starter section. This is our starting slice. It got a little squiggly up here. I'm going to try to see if I can clean that up later. But this is right here, 8 cores, so 68 turbines, all running happily with 2 fluorocatone plants. If you remember from the start of the video, I said that each plant can handle 1, so if you put 3 sets of speed modules, which each increase 50%, so 6, 300%, 4 times, basically means if you have these modules in there, every 4 reactors is going to correspond to 1 cryogenic plant. And this also is the one reactor where I did use end-on-end turbines because I needed to take the plasma that was always going to be coming out the side and flip it so that it always it comes down into here. So right here we again have essentially what's going on down here where the plasma is going, like I should iterate, the plasma flow goes down here and then it's going across. As you can see, these pipes are straight across. So it flows down this column and then it flows down the rows. And it's the same principle we've got here. It flows down this column and then it flows across in all these rows. And the reason this is exactly this size is because this is supposed to be an infinite reactor. Which means if we go to our blueprint and we grab our infinite slice over here and we put one down, you can see that we've got 4, because once you've got the basic setup, every 4 cores you're going to add corresponds to 40 turbines and 1 cryogenic with 3/4 speed modules. So we take that and we grab our little slice, we line that up right there, and then we can just extend it however far we want. And the fusion flows in, or the fusion cells flow in, everything powers up, and you can make this again as big as you want up until the and apparently I missed one little pipe down there, and I'll fix well, apparently I missed a few little pipes up here, and I'll fix that in the blueprint book before I upload it. But yeah, you get the idea. We have one big fluorocatone network. Again, you need to keep an eye on the pipeline extent on here because right now we're only at 78, but obviously if you're making some giant reactor, then it's going to get up much higher. And we need to put a little more fluorocatone in the system because right now this was set for the smaller reactor, so we just put a little infinite pipe to inject a little more fluorocatone in our little sandbox here, and you can see all the turbines will start lighting up and bring it up to full power. And you can see it's still perfectly ratioed. We have 24 reactors here and our 228, so 240, again minus 12, 228. It adds up perfectly. If you're building a very large reactor, you may notice some turbines don't turn on immediately. They will turn on eventually, it just takes a second. If I speed it up a bit, you'll see they'll all come to life. Plasma flows down to the bottom first, and then it flows back up. So yeah, as you can see, they will all spin up and be outputting at full power. So that's the infinite platform reactor. I'm relatively happy with this one turned out. As I said, I might find a way to make this part a little bit cleaner, but the way it tiles with the slices, I was pretty happy with how neatly that wound up working, especially with the fact that the 4 reactors winds up being exactly the same width as my little 8 turbine block. That's again one of those things where it's like, when you design it and you realize that's how it lines up, it's like, again, it's like, this clearly is what the devs intended, because it just lines up too perfectly for it not to be, where like the slices are exactly uniform width both for the reactors and for this particular turbine block. So as far as the blueprint book goes, which will be available in the description, there'll be a link to my Google Sheets which has all my blueprints. I will periodically update these as I think of new ways to design things or minor improvements. That's the reason I'm linking to the spreadsheet and not specifically to a Factorio bin. This blueprint book, probably a little bit more than the others, will probably have more reactors and more additions added to it. There's a bit more that I wanted to do as well, but this video already took forever to make, and I wound up getting it out about a week later than I wanted to. So at some point, I just have to kick it out the door. But here you can see we have all our reactor blueprints, or 1 core, 2 different kinds of 2 core, 3 core, 4 core. The planetary icon means it's sort of meant to be used on a planet. The platform icon means it needs to be used on a platform. Both icons means it can be used on both, but obviously there's a little bit of wiggle room in terms of what you put where. For example, I put a planetary icon on these, but you can easily use these on platforms. Well, this one on platform as well. So you've got your completed reactors up here for the planets, and you've got the platform reactors here. I have a 4, a 6, and keeping in mind that the smaller reactors can be used on platforms pretty easily as well. And then your infinite starter and your infinite slice. Down here we've got your 4 core tile for your reactors, and then all the different tiling blocks, including the one that I wasn't as big of a fan of, but who knows, you might enjoy it. And down here we've got our big blocks for our 88, 20, 28, 48, 88 turbine tiles if you want to make some really big tileable designs, but for some reason don't feel like using the infinite tileable reactor. One thing I would like to work on in the future, one reactor that I would like to design, but again, I have delayed this video long enough, is a wider version of the planetary reactor with power poles in the middle. Something where I can do a wider block like this, but much wider, or well, to be more precise, like this. But I have a feeling it might wind up being just being something like this with a couple turbines removed and putting the substations in the middle. We'll see. That's definitely the last big reactor that I think I want to design. But in the meantime, you can just simply tile the cores like this and use the existing tileable blocks to get yourself a nice, large, and clean-looking planetary reactor. So hopefully this helps you guys out and lets you design some pretty cool reactors. It's definitely a very fun thing to design around, and it's definitely a bit of a rabbit hole, because once you get into it, you realize that there's a lot of different ways you can do it, and it's very easy to spend a lot of time just sitting in the sandbox iterating on different reactor designs. Thanks for watching. I'm Stupid Fat Hobbit, and my Twitch is Twitch TV SF Hobbit.